Well, hi, this is Bob again, and we're going to look at section 2 of chapter 2. And I thought what I'd do is I'd break this down into a couple of, I thought I'd break down section 2 into two individual parts. They're very closely related, but we really need to get the main ideas down first. So both these lessons will be kind of short because I'll be dealing with just one particular data set. And we're going to go through and do the three requested graphs for each one. And I'm over on page 57, histograms, frequency polygons, and ogives. And as we've seen once before, an ogive is just another way of saying cumulative frequency. And we'll tighten up on that a little bit in my second recording for chapter 2. Well, I'm going to take a second and draw the graph of reproduce that little table on the bottom of page 57. But I'd like to, first of all, just read quickly the definition of the histogram. And it seems suspiciously a lot like a bar graph. It's because they're very closely related. And they tell us a histogram is a graph that displays the various data, and we're going to be using the high temperatures of each of the 50 states, which we've already introduced and carefully went over in 2.1, by using contiguous next to each other vertical bars, unless we have a frequency of a class of 0 or it's missing, various heights to represent the frequencies of the classes. So I'm just going to quickly and I can refer back here to maybe save a little time, but I'm going to take those class boundaries and frequencies at the bottom of 57 and just review us. And I'd like to remind everybody we carefully went through this question on page 47 earlier. So I'm just going to draw, Okay, now we're okay. So at the bottom there, we're just going to do a couple of these. We've got like class boundaries. And then we've got a frequency. And remember, we started off 99.5 to 104.5. These should be real familiar by now. Then 104.5 to 109.5. And I'll do one more, 109.5 to 114.5. Now the list goes on, but we can just refer back. As I said before, this is pretty straightforward stuff, but it doesn't hurt to take a look at it. And frankly, I'll be glad when we get into chapter 3 because my stylus and my new computer don't quite come off as nicely when I'm trying to do bar graphs and charts and so forth, as opposed to just the straightforward mathematical concepts that we're going to be seeing starting in chapter 3. But anyway, the frequency in our first class there was 2, and then 2 states basically fell in between the class boundaries of 99.5 and 104.5. And then our next class boundary set there was 8 for a frequency. And then our next one, temperatures from 109.5 class boundaries again to 114.5 was 18. Okay, this is more than enough for us to get going on the graph. And what I'm going to do is grab a new page and just do the graph. And I'll read through the steps that they tell us. You can read through the ones a little bit higher up there from the definition of the histogram. But this is going to be so straightforward that I'll just do it on a fresh page. And if you have a question, you can just come back and review. So it tells us to draw on X and Y axes. And our x-axis is going to be temperature, and our y-axis is going to be the frequency. So what we're going to do is, now you can go up by 2s or you could go up by 5s. The book goes up by 3. And depending upon how ideally you'll be using graph paper on this, but not everybody's graph is going to look the same, or your graph may not look identical to what the book's graphs look like, because they may have used a different numbering scale going up the y-axis. And they may have used a much bigger piece of graph paper, but ideally, I mean, if you plotted, there won't be any difference between the resulting graphs in terms of their accuracy, as long as you've clearly got the correct frequency with the height of the bars on the y-axis. I'll go up by twos, 2, 4, 6, 8, 10, 12, 14, 16, and I'm going up to 18 because the class, the 109.5 to 114.5, those class boundaries had the highest frequency of 18. Okay, so we're in degrees Fahrenheit. And then on the x-axis here, we start with our class boundaries. You don't have to start at the origin, but here's 99.5, here's 104.5. I can only eyeball it here. And I probably run out a little bit for my x-axis, but basically that's the idea. And again, I apologize that this is not coming out very good on my tablet here. It looks like the book gave us little ticks on the x-axis to help us with our graph. Okay, so how many, now we've got, and I should have put frequency, should have labeled the y-axis with a frequency, so I'll just pencil it in down there. So the y-axis is labeled as frequency, and the x-axis is labeled as temperature, degrees Fahrenheit. And when we flip back, to the bottom of page 57, we saw between 99.5 and 104.5 there was a frequency of 2. And if you want to shade them in, that's fine, but it's not necessary. They did it on the book, they shaded. And then in the next class, 104.5 to 109.5, the frequency was 8. So that's the height of that bar. And the next one we mentioned already, 109.5 to 114.5 was 18. Notice when they mean by contiguous, the bar graphs are sharing a side with them. They're next to each other. And then the next one had 13. That was 114.5 to 119.5. So I can only guesstimate, oops, you know what, I didn't take that one up far enough. I didn't read my own writing properly there. Okay, and then the next one was 13, and then from up to 124.5, 119.5 to 124.5 was 7, and then the last two were 1s each. Okay, so this would be, if we're labeling this here, this would be our record high temperatures. By state. And again, mine doesn't look very good, but I'm not using graph paper and I'm using a stylus here. But the idea of the lesson is just to show us how they lay out the x-axis with the class boundaries and how we label the y-axis our own choice, but I went up by 2s. And then we located those frequencies, the height of the frequencies corresponded to the heights of the graphs, and then we end up with a set of bars. And if you notice, this kind of, I think I've mentioned once or twice before, the bell curve, and those states and their high temperatures seem to suggest a bell curve there. That's something that we'll lead into start leading into in Chapter 3. Okay, well, let's go ahead and take a look at the second of our three, and this is a frequency polygon. I'll grab a new page here. And they tell us on page 58 that a frequency polygon is a graph that displays the data by using lines that connect the points plotted for the frequencies at the midpoints of the classes. So instead, we're going to do two things different. We're going to use the midpoints of each individual class for the heights or frequencies, and we're going to make a polygon from this. So instead of having bars, we're going to have, you can look over on page 59 in the middle there, you'll see we'll have a series of basically XY points, and each XY point there will represent a midpoint and its corresponding frequencies. So again, for time's sake, I'm going to take we're going to need our class boundaries. And this time what we're interested in is I'm going to write MP for midpoint. And remember, our first class boundary was 99.5 to 104.5. Then our next one was 104.5 to 109.5. And the next one was 109.5 to 114.5. Well, this is enough to get the idea here. And all I'm doing is reproducing the graph. Maybe it's slightly differently than they're doing at the bottom of page 58 and the top of page 59. If we want, we can make another column here for frequency. But anyway, what we need is to find the midpoint. And so we would, there's the way that the book shows us, there's another way, but we'll take 99.5 and 104.5, add them together and divide by 2, and they add up to 204, and when we divide that by 2, we get 102. And when we take 104.5 and 109.5, add those together and divide by 2, we get 107. By the way, there was a frequency of 2 in that first group there, whose midpoint is 102, first class boundary. And for our second one, it's 107, and its frequency, as you can see at the top of 59, and you've seen twice before, is 8. Okay, well, maybe you can see a pattern here. If not, you can do the next one. You can add 109.5 and 114.5, and they add up to 224, and when you divide that by 2, you get 112. Do you notice how each one of these is going up by 5 each time? Okay, so you don't really need to average each lower class boundary, or you don't really need to add the lower and upper class boundary and divide by 2. Once you see that they're going up by 5 each time, you can just write down the midpoints. Like the next one would be 117, then 122, then 127, and then our last one would be 132. So our first one's going to be 102, and our last one is going to be 132. Now, those will not touch the x-axis at 0, but I'll cover that last because we know that a polygon is a closed figure. From geometry we know that. And so we'll see how to stretch it out on each end to get the 0 points on the x-axis. Okay, now we're ready to simply plot or draw our graph, and I'm on the top of page 59, and I can just refer to that little table on 59 there. So I'm going to grab a new screen, and what I'm going to do is, like before, I'm going to have a X and Y axes. And again, I'll go up by 3s this time. Okay, and then on the bottom, our x-axis, this is the same thing, and I, again, should have written frequency. Let's see if I can turn sideways and write it. Okay, so on the x-axis, this is our temperature, degrees Fahrenheit. So here come the midpoints, and I'm not starting at the origin here. I'm going to start for the first one there at 102. I'll start right here. Okay, so mine is not going to look that good. It'll be a little tighter, but you can, of course, refer to the books. Excuse me. So our first one between the first midpoint corresponds to a frequency of 2. And then the next one corresponds to 107 corresponds to 8. I can get a little nicer points if I'm went up by 2s there, but the next one corresponds to 18, 112 and 18, again guesstimating. And then 117 and 13, back down now. And my x-axis is going to look a little tighter there. Then we go 7, 1, and 1. At 122 we have 7, and at 127 we have 1, and at 132 we have 1. So here's kind of where we're at now. Okay, and again, mine does not look as professional as yours will on graph paper. I think I've given you one of these to do. The same question that asks you to do the histogram and the frequency polygon and the relative frequency graph. So anyway, what we need to do is close this thing. We need to find the endpoints. And remember that the width of each one of these was 5. From 102 to 107 is 5, from 107 to 112 is 5, etc., etc. So what we do to close this thing is we subtract 5 from 102, which gives us 97, and that's at 0 because there was no temperature that was, we're using 97 for convenience, but we know that there was no temperature that was less than 100. But so this will close it on the left. And then we add 5. In other words, what I did was just take 102 and subtract 5, and I got 97 to close it on the x-axis. Now I'm going to take 132 and add 5, and I'll get 137, and that'll close it on the other end there. And by the way, I'm going to read what they tell us to do. It says, after we have drawn the graph using the midpoints, connect adjacent points, line segments, draw a line back to the x-axis at the beginning and end of the graph, the same distance that the previous and next midpoints would be located. Okay, so if this midpoint here, it was 102, then the same distance to the left of that, of course, would be 102 minus 5, or 97, and the same distance to the right of 132 would be 132 plus 5, or 137. And this would be our frequency polygon. Okay, well, the last thing in this lesson is to take a look at a relative frequency, cumulative frequency for right now. I got a little bit ahead of myself. I'm at the bottom of page 59, and we're going to talk about the ogive. And this is the third type of graph that can be used to represent the cumulative frequencies of the classes. And you may recall that I went through in 2.1 If you go back to page 49 in 2.1, we explained that the cumulative frequency is like a running a running count or accumulation of the individual frequencies, and we derived the graph, we derived that little chart on the top of page 49. So this one will be, to close off, pretty straightforward, but I'll read the definition of ogive. It's a graph that represents the accumulation or cumulative frequencies for the classes in a frequency distribution. Okay, so we're going to take, and this is what I like about this book, we have the same example that we started with in 2.1. We talked all the way through that, and now we've done the histogram and we've done the frequency polygon, and we're going to close off this lesson by doing the cumulative frequency diagram or graph. So what I will do is, again, that same chart that I just referred back to in in section 2.1, it's again shown on page 60, and I'll write the first couple of them down, but then I will just refer to them, and this not only saves time, but it makes will hopefully make the page not make the page look better. So here what we have is our two categories basically. Just to get us started here, we have values that were less than 99.5, a cumulative frequency I should say. And then less than 104.5. Remember, we're using the first one, less than 99.5, is our starting point. I should mention that they tell us okay, I've read they tell us here that the cumulative frequency is the sum of the frequencies accumulated up to the upper boundary of a class in the distribution. Now, 99.5 was not an upper boundary, but that's where we started off. But we need a place to start off, and of course the 0 is where we are going to do that. That would be the 0 point, or where the graph touches the x-axis. So the rest of these, you may assume that they're the upper boundaries. So 104.5, then 109.5, and then 114.5, etc. Now, remember, between the next value, between 99.5 and 104.5, there were two states. Now, remember also that between 104.5 and 109.5, you can just peek back a page there, the next one had 8 states accounted for, but we add that 8 to the 2 and get 10. Remember, we're keeping a running total here basically. So we go 0 to 10, then there were 18 in the next one, so less than 114.5 would be 28. Okay, so remember, this is a running count. Now, if you look on the top of page 60, and you see how I've just tried to derive a little bit of this graph, now we can go ahead and do the graph. And I'll grab a new page here, and they tell us that we need to label the x and y axes as before, but we're going to use a class boundaries, not midpoints. And it tells us, remember, when we're done all together for this, the states, this was not a sample. We had all 50 states' highest temperatures, so our N was equal to 50. And we're going to have to, when we're done with this diagram, we will have accounted for all 50 of the states. So that tells us that the highest point on the y-axis is going to be 50. So on the x-axis, we've got the class boundaries. And the y-axis, we're going to go from 0 to 50 basically, because we're talking about cumulative frequency here. So I'm going up by 5s. And again, I'm afraid my graph is not going to look that good, but if you're using graph paper, this can look really nice. So I'm going to start off at 99.5. And by the way, you do not have to start the graph off at the origin, 0, 0. We're only looking at the first quadrant anyway, so you notice that if you peek down to the actual graph where they're deriving it, not the very bottom of the page where they hooked everything up, but the diagram above that, they didn't start at 0, 0. They indented a little bit at 99.5. And then we've got 104.5, 109.5, 114.5. And then the last one that all accounted for 134.5. Well, again, I've already mentioned my particular problem with using the stylus and my screen. But let's go ahead and plot now, and I'm referring directly up to the top of the page 60, and that table there, and we've derived the table twice now. So at 99.5, and we've got 0, and at 104.5, I'll put a few of these on here. And again, I'm not, I've said it before, my spaces aren't anywhere near as equally laid out as we would be if we were using graph paper. But anyway, at 104.5, I can only estimate that. I'll say 2 is right here. At 109.5, we had 10. That one I should be able to get dead on. Probably more here. And at 114.5, we had 28. And at 119.5, we had accounted for 41 of the states. And then at 124.5, we were at 48 of the states. And then 49 and 50, I can just kind of estimate. Okay. So, when I use the term roughly, very accurately, okay, I slipped a little bit here, but anyway, what I'd like you to notice is this represents, again, our record high temperatures in the cumulative frequency, and they tell us that one of the reasons, we're going to see some other reasons in the next lesson, and a very good application of cumulative frequencies, or cumulative relative frequency actually in chapter 3 when we start talking about percentiles. But one of the things that they tell us that the graphs are used for, and I'm on the top of page 61, notice, for example, it tells us that if we wanted to find out how many record high temperatures were less than 114.5, we could go from 114.5 up and then read across and over. And we see there that at 114.5, this was supposed to be, if we want to put a point here, there were 28 temperatures already accounted for by 114.5 degrees. Okay, so so that gives us some kind of an idea. The other 22, in other words, over half of the states had highest temperatures less than 114.5. So that would be one use of this, and they tell us that they can represent cumulative frequency graphs are used to visually represent how many values are below a certain upper class boundary. And we've just shown that there were 28 values below the upper class boundary of 114.5. Okay, well, I will be back shortly with the very same ideas that we've just seen in this lesson, but we'll be doing something called relative frequency graphs, and they are also based on cumulative frequency. So there'll be a little twist there, but it's the same idea. So I'll be back shortly. Thank you.